Okay, so this video is going to be on dependent tree diagrams. The last lesson was on independent tree diagrams. We're going to see what the difference is between these two. And I've got a nice picture of a lovely, smiley, happy tree there. So, this setup question, we've got a draw contains 6 red socks and 2 green socks, solo socks, not talking about pairs. So right now, the probability of a red sock would be 6 out of 8 because there's 6 red socks and 8 socks overall. And the probability of green socks would be 2 out of 8. 2 green ones out of a total of 8. I wouldn't simplify these because it's going to make the next steps of your questions harder. I always say with probability, don't simplify the fractions. A red sock is taken out of the draw and not replaced. That's really important to notice whether it mentions if it's going to be replaced or not. We then need to say, well, what's the probability of red now? Well, it was 6 out of 8, but if I take a red sock, that goes. So what is left now? There's 5 red socks, and there's 7 socks overall, so that would be my probability of red. And my probability of a green sock, well, I've taken a red sock out, so it's not actually changing the amount of green socks I have, still got 2, but it is affecting how many there are in total. There would be 7 socks left, so 2 out of 7. And that's a really key skill, and that's what's different when we set up our tree diagrams. We're going to have to kind of look out for stuff like this. So looking at this question, there's 10 chocolates in a bag, 4 of them are milk, 6 of them are dark. That's why we've got this 4 out of 10 and 6 out of 10 from, with the milk and dark. First it's asking us to complete the tree diagram. I did that before, so I'm just going to talk through it. So if I took a milk chocolate out, this is what happens when I follow this top path. If I take a milk chocolate, well, instead of there being 4, there would be 3. And instead of there being 10 overall, there would be 9 overall. And if I take a milk chocolate, that doesn't affect how many dark chocolates there are, so there would still be 6 dark chocolates, but the total would be affected again, and it would be 9. If we go down this bottom path and take a dark chocolate, well, the milk chocolates wouldn't be affected. We would still have 4. You always just go back to this beginning bit when you follow your branches. There would still be 4 milk chocolates, but 9 overall because we've taken 1 out of the 10. And if we take a dark chocolate, well, there'll be 1 less dark chocolate in the bag. So there would now be 5 instead of 6, and there'd be 1 less chocolate bar in total, so 9 instead of 10. So finding the probability that we take 2 dark chocolates. So that's going to follow my path of dark and dark. So dark would be 6 over 10. Remember, we multiply these numbers. Times by 5 over 9. This would be 30 over 90. We could simplify that to a third if you wanted to, but you don't need to. So my probability of getting 2 dark chocolates would be a third. But you can see, the only thing different about these is we've got to do some, it's a bit harder to find out probabilities on the second branches, but the rest is exactly the same. We multiply across the branches, and if we get more than one option possible, we add them together afterwards. Finding the probability of getting 1 chocolate of each flavour. Well, 1 chocolate of each flavour, I'll do this in a different colour. This can be in green. That's going to be milk and then dark and then milk. So let's find these probabilities. That will be 4 over 10 times by 6 over 9. That will be 24 over 90. And this will be 6 over 10 times by 4 over 9. 6 over 10 times by 4 over 9. Again, that's going to be 24 over 90. So going to finish this question, well, we need to take these 2 values and then add them at that stage. So this is going to be 24 over 90 plus 24 over 90. That's going to get me 48 over 90. And if you did want to simplify that, that would be 8 over 15. Again, you don't need to, but either of them would be a fine answer. Just drop my pen. And then the final one. Find the probability of getting at least one milk chocolate. So again, I'll go to a different colour. We have all 4 probabilities, so this is just going to be a job of adding. At least one milk chocolate. Well, that's going to be this path, because we'd have 2. This path, because we'd have 1. This path, because we'd have 1. But not that path. So I've done that in my orange. So the probability of at least one milk chocolate is going to be 12 over 90 plus 24 over 90 plus 24 over 90. So doing that, that would be 48, and that would be 60 over 90, so 2/3. You might notice that we could have also done 1 subtract the only option that doesn't work. Or we could have done, because 1, all of these 4 should add up to 1. That's how probabilities work. So if we do 1 subtract the option that doesn't work, you'll notice we'd also get 2/3. So 2 ways of doing it, whichever way you prefer. So having a look at this question. 13 of the 20 students in Mr. Davidson's class are girls, so we're going to have probability of girls and then probability of boys. So the probability of girls at the start would be 13 over 20, and the boys would be 7 over 20, because 13 out of 20 are girls, so 7 must be boys. So I'm going to write them probabilities on my first branch only. If you pick a student, you can't actually pick that student again, can you? Because they'd be out of the pack, they'd be stood at the front, ready to do whatever presentation they're doing. So this would be a dependent one, because you can't pick the same student twice to do a task. So if I pick a boy, how many boys would there be left to choose from? Well, there was 7. If I take one out of that group, there would be then 6. And how many would there be in total? There was 20 sat down, I pull one to the front, there's now 19 sat down. If I pulled a boy to the front, would that affect how many girls were sat in their seats? No, it wouldn't, so there would still be 13 girls sat in their seats. And again, if I dragged someone to the front of the room, there would be 19 still in their seats, so 13 over 19. And similarly, for this bottom branch, if I bring a girl to the front of the class, that wouldn't affect the amount of boys still sat in their seats, so that would be the original 7. But then again, there would still be 19 left in their seats because there'd be 1 girl stood at the front. And if I brought a girl to the front of the class, there would then still be just 12 girls sat in their seats, and again a total of 19. Work out the probability of 2 boys being selected. So that in my orange, that would be this one on the top. So I need to do 7 over 20 times by 6 over 19. That's going to get me 42 out of... Sorry, I'm just doing my calculator. 380. So that would be 42 out of 380. And if you wanted to simplify that, you could say, well, it's not very simplified, 21 out of 190. Work out the probability of 2 girls being selected. So 2 girls, I'll go again in a different colour, would be this path down here, girl, girl. So that would be 13 over 20 times by 12 over 19. Again, that would be out of 380 because I've got the same numbers on the bottom of my fractions. And this time it would be 156 out of 380. And if you wanted to simplify that, it would be 39 out of 95. So an example where we've not been drawn the diagram for us, so this makes it a little bit harder. So first of all, ignore what they're asking us on the bottom. Let's just have a look at our information. So right now there's 12 sweets in the bag, 7 are lemon, so we want to find the probability of lemon, and 5 are oranges. So the probability of lemon at the start would be 7 lemon sweets out of a total of 12, and 5 orange sweets out of a total of 12. So drawing my tree diagram out, I'm going to have sweet 1 and then sweet 2. Notice how they've said without replacement here, or they might say that they eat it. That's another key they like to say. Obviously if you've eaten it you can't put it back in the bag. So I'm going to have lemon, orange, and I'm going to fill in these probabilities that I've found there. I'm then going to draw my second branches, and I'm going to have lemon, orange, orange. How about you try pause the video and fill in the 4 probabilities that should go here and see if you get the same as I do in a minute. Okay, so hopefully you've had a think about that. So if I take a lemon sweet out the bag, there would now be 6 lemon sweets in there and 11 sweets overall. If I take a lemon sweet out, not going to affect how many orange sweets there are, so still 5, but they would affect the total, 11. And then looking at my bottom branch, if I take out an orange sweet, not going to affect the amount of lemon sweets in there, still 7, but a total of 11 again. And if I take an orange sweet out, it will affect the amount of orange sweets left, so there would be, instead of 5, there would now be 4 and 11 sweets in total. Work out the probability that they are both lemon. So here I've got lemon, 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 orange, orange, lemon, and orange, orange. They are my outcomes. And then here I have my probability. So I want them both to be lemon. So it's going to be this top branch here. So 7 over 12 times by 6 over 11. That's going to get me 42 out of 132. So that is the answer to A. So I'll back my answer keys up here. A equals to 42 out of 132. Probability that they're both lemon. How about if they're both orange? I'll do that in a different colour. Don't think I can see that yellow. Doing this green. So they're both orange is this one here. So that's going to be 5 over 12 times by 4 over 11. So 20 over 132. So B, the answer to B is going to be 20 over 132. Obviously you can simplify them if you want to. Work out the probability that the sweets are both the same colour. So let's go for blue for this one. Well, if they're the same colour, that means lemon, lemon, or orange, orange. So it would be this plus this. So for C, I'm going to do 42 out of 132 plus 20 out of 132. That's going to be 62 out of 132. And then work out the probability that the sweets are different colours. We could go ahead and calculate these. So 7 out of 12 times by 5 out of 11, and then 5 out of 12 times by 7 out of 11. And then we could add them together, and that would be our answer. But seeing as we've already found out the other two, and we're just wanting to find these two left, what we could do is we could do 1 subtract the 2 that we don't want. So in this case, where they're the same colours. And we've just found out what that is. That's 62 out of 132 where they're the same colour. So 1 subtract that is going to leave me with 70 out of 132 for where they are different colours, and if we did these calculations and then added them together, we would have got the same number as well. But sometimes we want to look for a bit of a quick way to do it. Okay, final question. 5 counters in a bag. 1 counter is pink, 1 counter is green, 3 are yellow. They've drawn it for us here. So this is where we've got a triple tree diagram. So first of all, let's have a look at our probabilities. Probability of green, probability of pink, probability of yellow. Well, there's 1, 2, 3, 4, 5, 6 in there, so 1 out of 6, 1 out of 6. Can I count? There's 5. 1 out of 5, 1 out of 5, and 3 out of 5. So let's start drawing our tree diagram. So we've got green, pink, yellow. 1/5, 1/5, 3/5. And this is a pick 1. Then we can have pick 2 here. So they're taken without replacement, and it's taken at random. So find the probability that they are both yellow. So when we get a triple tree diagram, before we go ahead and draw it all, that's going to take us a while, just look for the paths you actually want. So we want both yellow. So as soon as we go up green and pink, we haven't gone for the path we want. So we actually just want to concentrate at the moment on this bottom path. So green, pink, yellow. So let's fill in that. So if I took a yellow counter out, that would affect how many yellows there are. So I would now have 2, and there'd be now a total of 4 counters in that bag. Imagine if I took that yellow out, I've just scribbled it out there, probability would now be 2 out of 4. So actually this is just the path we want. We don't need to write any more probabilities here for the moment. So probability of yellow then yellow is 3 over 5 times by 2 over 4. So 6 over 20, which is 3 over 10. So that's my answer to A. And then find the probability of a pink counter, then a yellow counter. So the actual paths we care about here is just this pink path. We don't care about the rest. So I'm going to set up this bit. So pink, and we care about pink counter, then yellow. So actually we don't care about what happens here. We just care about what's going to happen on this yellow. So if we take a pink counter out of this bag, I'll rub out this. So if I take a pink counter out of this bag now, like I've just done there scribbling, I would have 3 yellow ones still and 4 counters overall. So the probability of pink yellow would be 1 over 5 times by 3 over 4, which would be 3 over 20. And that is my answer for B. So you can see, if we kind of stop and think before we start going ahead drawing a massive tree diagram, we can make this question quite a lot simpler than it might have been, and a lot less work as well. We didn't even need to draw these two, did we? We only needed to draw 1, 2, 3, 4 lines and then do 2 multiplications. Okay, so there'll be a task for you on MathWatch, and hopefully this video helps. Let me know if you need any help otherwise. But that's it from me. Cheers.